I would like to present what we have as an approach there. So we address specific use cases by our partners ABB and Fagor. There are two of them that relates to formalizing requirements and identification of anomalies and evaluation of various security frameworks. So, there exist actually standards by NIST and other companies that give a set of requirements, set of recommendations on how to address various security flows in systems like Windows, Linux, application servers, and those requirements can be actually formalized with specific techniques. And something of that I'm going to show you just in a minute. So what are the needs? So what we address is that, okay, requirements come in various forms, like texts most of the time. But in some sense, we need to automate analysis of the security requirements. So most of the time it's done manually. So what kind of techniques we can apply to analyze? So our colleagues in MDU developed many various tools for automating that with model checking, with formal methods. We actually going to do that a bit from different angle. So with the object-oriented concepts, and I will show how to apply object-oriented thinking to requirements. And this is to simplify reuse of requirements, maintenance, and apply specific automation techniques. Right. So to say, we have prepared specific library or a framework that we call RQCODE. It is available on GitHub, and if you can distribute the slides, so there will be a link to RQCODE framework. So inside we have prepared concepts, examples. We also implemented some temporal patterns so that we can express temporal properties through our framework. And we also prepared a set of examples for Ubuntu Linux and Windows, implementing recommendations that are provided by a security technical implementation guide. So what we currently want, we actually gathering feedback from our industry partners, but also from the community, so that we can discuss whether our hypothesis about the reuse and maintainability properties of our framework are relevant. Okay, so let's start with the RQCODE concepts, and I have a couple of very simple examples to show you what does it mean, what we mean by lightweight formalization. First of all, our main concept is that instead of text, we can combine actually textual statements of requirement with the test cases that address whether this requirement is satisfied or not. It is very similar to the concept of behavioral-driven development. When you start development, you start with a test, and then you develop until the test is satisfied. The similar thing we can actually apply to security. So we can have a set of security requirements that are formalized as security tests. And until your system implement this security test, I mean, your development is not finished. Our particular requirement of the code concept is based on the work by my colleague Alexander Naumchev and Bertrand Meyer. They actually had some theoretical baseline called seamless object-oriented requirements. And we try to mimic this experience with just, let's say, Java language, so basic purpose object-oriented programming language. So our hypothesis that we try to validate with that, and we try to promote, is that like creating this kind of requirements classes helps with lightweight formalization of security requirements, and like manipulating requirements in this notation helps to easily combine the requirements, to integrate them, to reuse, to maintain, and also it is easier to trace those requirements. Okay, and so with that we created in Java just a bunch of classes, very basic, like for example, a requirement class would contain a statement, a textual one, a textual statement, what system should do, what system should not do, what environment should do, what environment should not do. And it also provides a check methods where an expert would put a test, specific test, whether this requirement is satisfied or not. Because in our thinking, a requirement is well specified when you can verify it. And if you can verify it, you should put this verification specific methods. And if you can do that, so you are done with specification. If you cannot verify a requirement, it is not a good requirement. So basically, you cannot do. And so formalization means that from a textual statement, I can create a test case that validate my requirement. Okay, so, and this is a basic concept. So if I can verify and I have verification method, my requirement is formalized. So it could be, so we said, okay, there are many verification methods. Testing is very much in use. It's not ideal method, but it's something that very much in use and popular. So let's put test cases for those security requirements. And at the end, we can obtain whether this requirement is satisfied, passes, fails, or it's incompleted. Also, just as a kind of extension of this concept, they could be enforceable requirement, meaning that sometimes we can provide countermeasures, and we can say with specific methods like enforce, I can enforce or force some requirement to be implemented. This could be, for example, you have a requirement, this particular port 23 should be always closed, right? And you're checking this and it's not closed for some reason on the system. And with enforce, you can trigger some kind of behavior that would shut this particular port down. And so there could be various examples for that. So it's useful to have also checking and enforcing mechanisms within the requirements specification. Right. So this is basic concepts. So now I will show you an example how to manipulate this basic concepts to specify something about requirement. Let's consider an example. So we have a clock with only one arrow that can tick. So, and which one tick, I increment the seconds by 1. So I adding up seconds. So we can have a requirement. So when a clock ticks, we increment current seconds by 1 till it is smaller than 59. So the requirement would be stated like in textual natural language notation as a clock tick increments current second if it is smaller than 95. Okay. For that, like to verify, to check that this is implemented as it is specified, we can like make a simple test. For that does exactly the same. So checks if seconds are less than 59. We check when we tick that the seconds are augmented by 1. And if clock seconds are not less than 59, so that actually should fail. So it should not work. Should not increment by 1. That is actually implemented literally what is said in the natural language statement. Okay. Also, we can notice some particular problem in this requirement right away. So when I was actually implementing this example in Java, I kind of when trying to figure out, I noticed actually a problem right away that, for example, we don't talk what happens if seconds are negative. So if for some reasons seconds become negative, they will be still incremented, and so the seconds in clocks they cannot go beyond 0. So it should be between 0 and 59. So we can actually add up and extend this requirement, adding a new condition. So for example, we can say requirements number 2, clock seconds value must be between 0 and 59. Okay, this will kind of reinforce our previous requirement. So what we can do, we can use the object-oriented approach for reuse, for extension, and derive is a following requirement. So we extend, we derive this tick boundary requirement from a previous requirement 1 tick increment requirement. So we're adding up a new condition. So we first check that first one is satisfied, and then we check if boundary condition is also satisfied. And so with that, we can actually build up a system of requirements by using this extension mechanism, so inheritance mechanism in object-oriented terminology. Right. This one could be helpful. Sometimes it's suggested to use this one, but it may be often very much complicated for the in the systems. Sometimes we can also create new requirements instead existing one by simple association or using them in sequence. So in this example, we use a combined tick requirement, which takes, executes subsequently requirements 1 checking and requirements 2 checking test cases. So we say this combined requirement, and it is satisfied only if the both requirements, like increment requirements and boundary requirement, are satisfied. And so with Java, we can actually quite simply create a class that specifies those kind of things. Right. And basically, this is all. So we just showed you basic concepts, how to derive, how to specify requirement with a test case that associated, and how to derive and combine various requirements. So this is 2 elements and operations that we can use. Now we can actually talk about more advanced topics and add up some temporal patterns. So sometimes we say this requirement, this port should be always closed. This is a kind of temporal requirement, or this port should be closed for 10 seconds or for 20 seconds, or the response time in this particular case should be below that particular value. So this is what is called temporal properties. And there is quite interesting work, very old but very famous, that studied about 500 temporal properties, and they discovered that these temporal properties always follow similar patterns, and in most of the cases, all these 500 different requirements could be described in terms of 6 patterns, like global universality, eventuality, response time, and various time properties. And with these 6, we can describe quite a lot of temporal properties. And so what we decided, we said that we actually will create that in RQCODE, and we have a specific library of these temporal patterns that would check whether a requirement, any that you specify, holds for specific number of time or have specific sequence of like checks for requirement. So, for example, if I want to check that this particular port is closed, I can go and check for 10 seconds or 10 hours. I can go and check with some period that this requirement holds. And so all of this temporal requirement would rely on specific class that we call monitoring loop, and we will monitor from time to time what is current state, and so whether requirement that we specified is implemented. So to give you a concrete example, so we have our requirement 1 that tick of the clock should increment seconds by 1. And if you, for example, want that this requirement holds at least for 10 seconds, okay, so we can combine global universality pattern with our tick requirement and just say, okay, just check for 10 seconds that this one holds. And this will automatically, let's say, set up checking of this property for 10 seconds, but also this new timed requirement will also will have human readable text saying the requirement, the RQ1 that states should hold for 10 seconds. So that will be actually combination of requirement in natural language plus specific testing for this one. Okay, so this is how we do with temporal properties. Actually, we went quite beyond of that. So we showed you specific concepts, very simple one for requirements as code, as tests, but this can also be applied to security. So our main interest in this project is whether we can apply this, let's say, behavioral-driven development to security properties. And our partners are quite interested in security technical implementation guide, and this guide shows provides various recommendations for various systems like Linux, Ubuntu Linux, Windows. It provides various meta information, but also provide description. Like one requirement would be that Ubuntu operating system must not have network information service package installed. And for that, there is specific reason for that. But this recommendation also will give ways and scripts how to check that this requirement is satisfied, and also if you want to enforce and kind of remove the package, that will give us specific script how to remove remove this package. So we can take our RQCODE requirement classes and just extend that. Stick would be extension of that specific meta information. So for simplicity reasons, I would like to show you how easy it is to create patterns using or reuse specific requirements in RQCODE. So we notice that there is quite a number of recommendations that require you to install or disinstall or remove specific packages in Linux system, right? And instead of like creating one class on one script per this requirement, we could actually extend that and say, okay, I will have a class called Ubuntu package pattern that will specifically deal and verify that a package that I want is installed or disinstalled. And to create a new requirement, I will just provide this package a specific parameter that say, okay, this should be present, this should not be present. And my requirement, like for example this one that I read to you, like Ubuntu operating system must not have network information service package installed. I mean, I will only need 3 lines of code, actually 1 line of code, just to put what kind of package I should not see in my system, and this will update the whole requirement, the text that people can read, and also will have specific behavior that will check that the package is not installed. The same could go also for the other requirement that states that this RSH server package should not be installed. So also 1 line of code, and it updates the behavior, it updates the text for requirements, so I can read. I can have this readable form of requirement, and I can already have a test that check that my requirement is satisfied. And the same can be done for all other requirements of this type. So it's a simple one, a simple case. We can see that we can reuse quite easily the requirements classes in this way, and also we can verify trace execution and see whether it's implemented or not. Also, what is interesting to notice, in case I want to migrate from one operating system to another one, we can imagine that the stick guidelines for Linux can be also applied to other Linux systems like CentOS or like Red Hat Linux or others, which have different types of packaging system. So, for example, here we use apt-get as a kind of routine apt package manager, but other systems use something else like RPM. And instead of checking each of the various scripts that have to check whether the package is present or not present, I can only change my class that does this kind of working with packages and kind of configure that. And then all these requirements that we have specified can be applied to a new system. So for migration, for maintenance, this system presents some particular advantages as well. Okay, this is a basic concept. That's all that I wanted to show today. So also for someone who is interested, you can apply various temporal patterns. So checking that this package is never present in the system. So it could be a temporal property, and by combining temporal requirement and this requirement, you can actually have a system that verifies that this requirement is satisfied. So our framework is available on GitHub in VerDevOps organization under RQCODE repository. It contains basic concepts that I showed you, temporal patterns that I showed you, and many examples for sticks, including those for Ubuntu and also for Windows 10 system. We will be happy to have your feedback about the system. So in case anybody in the audience would like to try out, so we'll be happy to show how it works, and also to gather your feedback about the system. So with that, I thank you very much for listening. My name is Andrey, and